welcome. Here we are. Let's see if this is working. I think it is. Let's see how it goes. Just give me a moment here. Goes. Is it working? Just give me a moment here. Yeah, it's fine. Oh, it's good. Yeah, I've been procrastinating, so I haven't streamed in a while. All right, let's take a look at some of these questions. Let's get right into it. We're gonna just do like an hour today, I think. This question, by the way, this count triplets, I think you can do an O of n, O of n time, O of n time, O of n memory. By the way, not just O of n squared with another optimization on top of the other one we saw the other day. That was a cool question. So let's do maximum number of coins you can get. Let's try this one. Yeah, I've been kind of procrastinating. I've been really tired and been avoiding streaming basically. I was going to stream a few days ago, but I didn't. There are 3n piles of coins of varying size. You and your friends will take piles of coins as follows. In each step, you will take any 3 piles of coins, not necessarily consecutive, of your choice. Alice will pick the pile with the maximum number of coins. You will pick the next pile with the maximum number of coins. Your friend Bob will pick the last pile. So let's say AXB, pick the last pile. Until there are no more piles of coins. So maximum, and then what does Bob pick? Give an array of integers, piles, turn the maximum coins that you can have. Okay. So 2, 7, 8. Bob 8, 7, Bob the last 1, 2, 4. Alice picks 8, you pick 7. Alice picks 4, and you pick 2, Bob last. What is the last one though? Like, is it any of it? 7 plus 2 is 9. And if we choose this arrangement, 1, 2, 8, 2, 4, 7, I get 6, which is not optimal. So 2, 4, 5, you get 4. 9, 8, 7, 6, 5, 4, 3, 2, 1. So it would be 9 and 8. So you get 8. And then I guess he picks 1. And then you have 7 and 6. He picks 2. So you get 2, 6, so you get 14. 1, 2, 3, 4, 6, 7, and then you pick 5, 4, and 3, I guess. So I guess you pick the 2 maximum and the minimum. Interesting. So I guess if you sort this, the first third is sorted ascending. The first third is always going to be the smallest ones, which are just removed. The second third is basically I guess you get every second element from there, so I guess it's something like the follow. Let's try this. I think it's something like this. Let me just rename this to V. So let's do. It's going to start off at n divided by 3. And it's going to be I plus equals 2 plus equals v of I is less than n. Something like this. I think that's it. Let me actually put this right here. Hopefully this works fine. I think this is it. I think this is it. I'm not sure if there's a better way to do this. Let's check the constraints. 100K, 10,000. Yeah, you could probably use a counting sort to do this faster, asymptotically faster. I'm gonna just try it, see if it's correct. I don't know if it's correct. It's right. Okay. That's a little slower than I was expecting. I mean, this is relatively fast. I think the counting sort is a little bit faster. I think that might be why it's not 100%. It's technically n log n because of the counting of the sorting. Just to see what happens, let's try counting sort, see how that goes. Wondering if there's an even better way to do this. I'm gonna try one more time to see what we get. I'm gonna try a counting sort. I don't know if that's really necessary. It may or may not be faster. It's probably not necessary to do that. Replace each num with the sum of its digits, return the minimum. Okay. So we could probably just do reduce. It's probably fine. I just rename this V again to keep it a little bit easier. The initial is going to be there's only 100 numbers. We'll just put like 10,000. Let's keep it simple. I don't know if I can do this. I can maybe do it this way. So this is the reduce, and this is the transform. So we'll come back to the transform. Reduce is pretty straightforward. And the transform is going to be int, and we're just going to say int equals 0, 4. I mean, we could also do this too. Don't have to make it so. This is not going to be a constant anymore. Okay, let's try this. So we take modulo 10 to get the last digit, and then we divide by 10 to shift to the right. Something like this should work. Yeah, that's pretty straightforward. All right, we'll go to the next one. All right, how's the stream doing here? Just check stream health. Oops, not that one. This one. We're about 8 minutes in. It's good, but it's got a warning. Okay. All right. Sort the matrix by a diagonal. Send by n square matrix integers grid. Return the matrix such that the diagonals in the bottom left triangle, including the middle diagonal, are sorted in non-increasing order. Non-increasing, so kind of decreasing, sort of decreasing, but non-increasing order. Okay. Bottom left triangle, diagonals in the top right triangle, so sorted in non-decreasing. So non-increasing and non-decreasing. And the middle one is going to be non-increasing. Okay. Interesting. Okay. So non-increasing. All right. I think I understand. There's a curious thing here. So there are a few ways you could do this. I think probably the easiest thing is to take the elements on each diagonal, dump them into an array, sort the array, and then read back out the elements. That's probably the easiest approach. So that way. I like that one the best. Just got a temp array. It's an n by n grid, so we can just take the size. And reserve n. So we could say for int I equals 0 is less than n. Plus I, this is going to be for each diagonal. And there are actually 2n of these, 2n. You go up one side and up the other side, and you would subtract 1. So it's more like this. This is for each diagonal. And then we're going to say, actually, you could do easier than that, would be just do I less than n. Oops. Let's do I less than n for the first diagonals. And then do I is less than, and yeah, I think it's less than or equal to n is fine. Well, I is 0 less than n, would do 0 to n minus 1. That's 0 to 2n minus 1 inclusive is 2n. We actually want to do 1 less. We do want to do 1 less. If you go to 0 to n minus 1 is going to be the, okay, it's a little confusing, but that's right. Anyway, this is going to be non-increasing order. Okay, so temp for, could actually, yeah, we'll do for, we're going to clear temp first. For, now reading off the diagonal, what's the tag size? Starts off at 1. Might be easier to do it this way. And then this diagonal size decreases. Right, so the diagonal size when I is n, I don't know if this makes sense. Also, I think I can, maybe do it this way. Might be easier to do it like this. I mean, yeah. Actually, I think of like a easier way to do this, a way that makes more sense. And just reset it to like n minus 1 or something. On the diagonal itself, it's going to be n, but I think this one handles the diagonal. So actually, we're going to update it to n minus 1 for the first iteration here. Okay. Same thing. So int j equals 0, j is less than x, nice. This plus j, and the way this is going to work is going up the diagonal. We'll go up the side. So this is going to be the row. I is going to be the row at the bottom, really the bottommost row. We're going to temp dot push back. There's a way I used to do this. That was maybe a little bit better. I would usually have a starting point and then I'd have a like direction, I guess. Um, but this isn't. It's this is fine. I think this is fine to kind of figure this math this out instead of like abstracting it a little bit. So it's gonna be a grid of n minus I minus 1 at the bottom. That's the row. And then the column is going to be the 0th column. And the row is, we're going to, oh yeah, well, when I changes, it goes, yeah, it goes up. But also J, it's going to add J to move element by element. And then J is also the column. Yeah. A little bit confusing, but that's the way to do this. Or one of the ways to do this. Then we're going to sort temp. And then read each of these values from temp of J. And we said this is going to be non-decreasing, so it's actually going to be I think it's like greater or lesser than greater. I have to check what that's supposed to be exactly. Yeah, a little bit confusing. And then the similar code for the other side. There's a better way to do this, by the way. There's definitely a better way to do this. And now on the other side, it's going to be the column. It's going to be the starting point. N minus I minus 1 minus J plus J. So it's definitely plus J for the column. Well, as the column's still increasing, plus J. But the initial column, I think it's just 1 plus J, frankly. I think so. Or diagonal size, maybe. No. It could be like n minus diagonal size. Or diagonal size minus n or something like that. I think it's n minus diagonal size. Because the diagonal size is going to decrease now, yeah. N minus n. This is first column. The diagonal size is going to be n minus n minus 1. It's going to be 1. Yeah. That's the right column, and then it's going to move down to the right. And then the row is just plus j. It's just j. I think this is the right idea. Yeah, as I'm saying is I think if I abstracted this, I could do it a lot faster. I think that's correct, actually. And then this is just going to be a normal sort. Oh, man. Gosh. Okay. This might not be correct. This is a bit messy. Oh, it works. That's right. Okay. I'm going to go for it. This is probably correct. I'm not sure. There might be a better way to do this, by the way. But it seems like this is around about as good as it gets. It's pretty good. It's a pretty good approach. Not a great approach, but reasonable. All right, it worked. Okay. I mean, it took a while to program. The other way to do this is like abstracting this away a little bit so that you have a starting point routine that or not a start, but just an initial point, and then you have a routine that like it'll have like a direction vector through the grid, and you can allocate, like you can save the elements from that direction by like repeatedly moving in that direction, and then also then write what you saved in that same direction, in that same pattern. Um, which is a little more, like I said, a little more abstract than what I did here. What I did here was a little more like kind of hard coding the directions and stuff, but you could abstract that and have like do the direction sort of pattern thing as kind of its own sort of like subroutine, I suppose. Um, it's a little more complex than that, but it's the basic idea. Like that's what I did here. I think it just took a lot longer to program because I had to kind of math out all these different parts, which you don't need to do if you abstract it. Then all of that becomes like much easier, I suppose. Yeah. I guess you'd have to write like code that like gets in the pattern that you want, and then also writes in that pattern to the grid. And you could write like I guess you could write two lambda expressions that do that. Um, so writing in a pattern and then getting in a pattern. And the pattern would just use like a direction vector, like a delta x, delta y kind of thing, or delta row, delta column. Um, and that would make this a lot easier. That's like a much better way to solve this because it's very fast. It's fast. It's efficient, and it's also very fast to program. Um, so yeah, so it wasn't great on my end doing it this way, but it was at least correct and efficient. It could have been programmed like in a few minutes instead of like 10 minutes, or however many minutes it took. We could have done it a little faster. All right, we got stocks. They want report the capital gain loss for each stock, total gain and loss after buying and selling stock one or many times. Result table in any order. This is the follow example. Operation day, operation buy, so. Okay, so we're gonna get all the buy prices summed together. For each stock, and then so handbags is negative 2,300. So for each stock, we get operation day. Oh, I guess that's how many they bought during that day. And we're gonna add all the buys, and then add all and then subtract all the sells. Or yeah, I think you subtract the buy and then add the sell to get the gain. So they bought 17 at 30,000 and they sold 29 at 7,000. I don't understand how you can sell 29 that you. I'm not really sure. What is going on? What? Oh, excuse me. Okay, I see. So you add the sell and you subtract the buy. Okay. I'm assuming like this is gonna make sense if I do it like that. All right. I mean, it's a little awkward, but yeah, you could do this relatively easily. I think you can use a group by operations or group by syntax. So it's select from stocks group by stock name, and it's gonna be what do they want? They want stock name, capital gain loss. Stock name, that's gonna be sum over minus this difference as capital gain loss. And the sum is the price. Oh, excuse me. Oh, we need like another subgroup. The buy. call it buy price. Okay. Something like buy price, buy sell price. I have to double check how this works. So SQL. Let's suppose I have column to buy, either buy, or sell in a table. One, to sum a price column. Only the buy entries. How about HMS? I was thinking about doing like a where clause or something in my sum, but I'm not sure about that. You can use a conditional aggregation with sum and case, or sum with if to equivalent approaches. Some case when. Oh, then else. Oh, interesting. So there's case and if. Ah, interesting. Oh, wow. Okay. So case and if, which is better. We're gonna do if. Operation equals buy. And this is going to be if operation equals sell. Yeah, I should have actually known this, but functionally equivalent, performance is nearly identical, conditional aggregation. Okay. Case for compatibility with other databases. If you're strictly working with MySQL, use it brevity. Okay. Not bad. Wrong answer. Oh, that's brutal. I think it's the other way around. It's sell by the way. I think that might be part of the issue here. What's the stream health doing here? Looks okay. Yeah, that's probably correct. Let's give that a shot. It's probably that simple. Let's find out. Yep. Okay. There's other things you'd ask about or think about there, but that's probably like enough. Given a sorted array nums of n non-negative integers and an integer maximum bit, you want to perform the following query n times. Non-negative integer k less than 2 raised to the maximum bit, such that find a non-negative integer such that nums of 0, nums of 0 XOR nums of 1 XOR XOR nums of nums dot length minus 1 XOR k is maximized. K is the answer to the ith query. So there's some non-negative integer. Find k that maximizes this XOR. So we XOR everything basically, the entire array. I want to find k that maximizes. Okay, well it's basically just flip all the bits in, and it's you got to flip all the bits that are. So what you can do is you could just take 2 raised to the maximum bit, subtract 1, that gives you a mask of 1s from right to left, and then you XOR that with this XOR. First you AND it. Oh no. You XOR, and then with this, and then you AND with that mask again. XOR the mask and then AND with the mask. The reason you XOR is that it'll basically delete all of the bits that you want to like remove. It'll also give you some junk to the side, to the left side. And then when you and with the mask again, it'll remove the stuff on the left side. So calculate this XOR, calculate this max K, which again use some bit manipulation, and then remove the last element from the current array nums. Return array answer, answer right, say answer the query. So you can do this in linear time. This is pretty straightforward. Answer as follows. So query 0113, and then in order to reduce the XOR value, you could just XOR from right to left to like simulate removing the element. So you actually don't have to touch anything beyond that. So you could use constant memory for this, I think. 0 XOR 1 XOR 1 XOR 3. Okay, case 0, case 3. So 0 3 2 3. Okay. All right, this is pretty straightforward. Let me see. Oops. Let me just see what the constraints are. Just double check them. 100,000 maximum bit 1 to 20 inclusive. Okay, that's fine. Yeah, so I would say int bit is just going to be max bit. I'm just going to say max bit. And we're going to bit chef that. 1. Mask is going to be bit -1. So we're going to say or just int current XOR is num stood. Could do, I'm just going to rename this to accumulate, I want to say. Let's do like reduce. I think accumulate works. And we just want to use stood bit XOR. And then we're going to say for auto where b dot begin might be not equal to b end pointer we reverse end. Also, hopefully you can hear me speaking here. I hope I'm being loud enough that you can actually hear me. Yeah. Not speaking very loudly. So for each of these, we're gonna say there's a result vector. Oops, yeah, result vector. Whoa. Okay. And they actually want to go, I think, to right to left. Yeah, it's right to left. So result dot reserve b dot size, and it's going to be v a result dot push back. And what did I say? It's going to be take the current XOR, and then we're going to XOR it with the mask. And then we're going to AND it with the mask. And yeah, that's the value of K. And then we're going to current XOR current XOR equals dereference pointer, something like this. It's something along these lines. Compiler. Okay. All right, maybe this doesn't quite work. I might need an initial value to accumulate. I'm not sure. 1,000, 2, 1,000, 3, 1,000. Yeah, okay. All right, that seems to be correct. That seems to be what they're looking for. How are we doing on time? 35 minutes? Okay. Not too bad. Yeah, that's what they wanted. Percent. It's not too bad. Let me check the health of the stream. It's healthy. It's good. I think I want to. I'm gonna submit one more time, and then we'll go to the next question. How many problems have I solved so far? Or excuse me, how many minutes? So it's 36 minutes. It's been a few questions. So yeah, there's some variation in the runtime. Yeah, that's okay. That's okay. I'm not sure how many questions have gone through so far. It's a few. Rearrange array elements by sign. Zero indexed integer array nums of even length consisting of an equal number of positive and negative integers. Turn the array of nums such that the array follows the conditions. Every consecutive pair of integers have opposite signs. For all integers of the same sign, the order in which they are present in nums is preserved. The rearranged array begins with a positive integer. Modified array after rearranging the elements. Okay, so basically a kind of stable sort that basically interlaces the even, the positive and negative. That's fine. So we'll just dump the two into two different arrays and then interleave them. I think that's probably the easiest way. There might be a way to do this that saves some memory, but let's not make things too complex. So we'll say positive, negative, positive, reserve, yeah, reserve, and nums.size. We'll rename this to V again. It's a little bit easier to type. Size, negative, reserve, size. And then we're going to for const int x in v. If x is greater than 0, positive integer constraints, absolute value between. Okay, so it's never equal to 0. All right. Just gonna double check. So we'll use else. Positive pushback x, negative pushback x, and then we're gonna just say int I is 0, I is less than v.size, I guess. Yeah, v.size. And then and we'll just keep it simple and just do ijk. Just keep this real simple. And then we'll say result. Let's go back to that. This should be actually. Yeah, actually, that's fine. That's fine. I'll just do it that way. It's results. Same deal. Observe. Size. Return result. And we're gonna say if I and 1. Otherwise, or actually, you could even do, yeah, let's do it simple. I'm gonna say result dot pushback positive j. Otherwise, result dot pushback negative of k, and increment j, and increment I. Okay. And is it supposed to start with negative, or supposed to positive or negative? every consecutive pair of opposite signs begins with a positive integer. Okay. So if it's yeah, we'll flip these two then. I was gonna say, I think I gotta flip these. All right, let's go with this. Let's go with this. Negative, probably not. Negative is probably not gonna work there. Negative. There we go. All right, I think that's it. We're gonna just keep it simple and do something like this. Can make things a little bit more optimized if I want to, like, if I can make these arrays that I'm using, I make them static, the memory. Let's see if we can optimize things a little bit here. There's probably a better way to do this, but let's do like something like this. Yeah, we could do static. Oh no. I think I can do it. I'm gonna try this. This is maybe not a good idea, actually. I'm gonna try it, see what this looks like. Oh, okay. Oh, my computer is struggling. I think I need to. I probably need to restart my computer at some point. I have a tendency to not to restart it soon, as often, frequently as I should. Probably shouldn't be static, actually. That one I'm not sure about. I wonder what this does. I wonder if this is even correct. It is. Let's try it. This may or may not be better. I don't know. Oh, it's faster. Oh, it appears to be faster. I thought that might be a little bit better. Uses a little more memory, though, I think. It's a slight. No, it's not much faster. It doesn't really do that much, I think. Sometimes I think these sorts of tricks do something, but it doesn't really look like it does much. Okay, that's one way of doing it. I mean, yeah, just a really simple approach, I think, does the trick. Oh, I solved this one already. Let's just quickly describe how this can be done. Swap all f and m values. Single update, no intermediate temporary tables. Let's write a single update statement, but not write a select statement for this problem. So there's probably an update routine, and basically you would just have like an if statement where if it's, you could have like a nested if statement. So you would return, you'd say, whatever this is, this column name is going to be set to, and then an if f, then return m, else if m, return f, right? That's probably the simplest way to go. There might be a better way, but that's probably the easiest. That's probably what I would do. I already got this one, so I've solved a lot of the questions already. Or I solved a significant number of questions already, so that happens from time to time. All right, how are we doing on time? 44 minutes, and stream health is good. Positive integer num consisting only of digits 6 and 9. Oh, okay. Maximum number you can get by changing at most one digit, 6 to 9, and 9 becomes 6. Okay. You can only change one digit. What's the largest you can? At most one digit. So the leftmost 6 becomes a 9, and that's it. How big are these? They're small number. There actually are not very many numbers to pick from here. You actually could probably hard code this. The number of cases is very small. There's only 10 up to 10,000, but there's only 2 digits to pick from. 10,000 means, and it's less than or equal to 10,000. Well, 10,000 is not included. Only 99,999 can be included, right? You can't get to 10,000 because it doesn't have the 6 and the 9 and the 1's position. So it's less than or equal to 9,999, which means it's the most four digits. Four digits between 6 and 2. You only have 2 to the fourth possibilities, which means you have at most 16 possibilities. Yeah. With you can maybe make it a little more complex by saying that you can do 3 digits, 2 digits, and 1 digit, but that would just be the sum 2 to the fourth, 2 to the third, plus 2 squared, plus 2 to the first, which is still like pretty low. It's around what is that? 16 plus 8 is 24, plus 4 is 28, plus 2 is 30. It's only about 30 possibilities, I think. Yeah, so you could hard code this if you wanted to. But the easiest way to do this is just and result 0, return results. So we're gonna loop through the digits and append them to result. So we're gonna say num greater than 0, num divide equals 10, digit equals num modulo 10, result times equals 10 times the result plus the digit, and say if digit equals 6, set digit equal to 9, and then and bool check, or just idempotent, or just once, false, not once. And just this one. Actually, the last. It should be the last, the most significant digit. So, ooh, uh, that's a little awkward. You can't quite do it this way. This will give you the least significant, but we want the most significant. I mean, there are some other options here that one can use, but I'm trying to think of a more clever way. It's like doesn't require like turning into a string and reversing the string or something. Um, Probably the easiest thing is to do this. All right, fine, fine. We'll go this way. We'll do it this way. We'll just do it this way. Digits. Um, I will just do auto where begin or end. Maybe we'll do this. And pointer and pointer is not equal to 6. So we're gonna go left to right, or we're gonna go backwards for the most significant. Until we get to a spot that's a 6. Yeah, and then now the pointer is a 6, and so if pointer is not equal to digits are end, then we're gonna set pointer to a 9. Now we can do result equals n times result plus digit. And this can just be constant d. It should also go in reverse, shouldn't it? Can also just reverse these digits. That works too. Okay. I don't know if that's better or worse. I don't know. It seems. Yo, where are you from, dog? What's up? Dev Brothbisht. Dev Brothbisht. Compiler. I'm from the United States. The USA. 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 United States of America. Yeah. Oh, I don't know why I missed that. I missed that twice. There we go. It looks like this is right. I'm gonna go for it. This is probably right. Few typos there. There we go. Yeah, I mean, maybe not the best way to do it, but reasonable way to do it. It's reasonable, given that there's only 4 digits to work with here. Let's submit again for the sake of it. Let's continue. How am I doing on time? Stream is healthy, relatively healthy. Time, we got another 10 minutes. So I was just gonna do about an hour to see, just do a little bit today because I felt kind of guilty not doing any problems for a few days on stream. Given a 2D integer array tasks where task sub I equals s sub I, t sub I, each s sub I, t sub I tasks represents a task with the start time s sub I. Takes t sub I units of time to finish. Return the earliest time at which at least one task is finished. Start time. Oh, okay. So you would take the start time plus t sub I to get the time for completion. You take the minimum of these. S sub I, t sub I. So we're going to take return, stood, transform, reduce. And it's going to be, I'm going to just call them TS tasks. TS begin, TS end. 0. I'm not sure actually what that should be. Transform. It shouldn't be too hard. The reduce should be, I'm actually not sure if I need an initial value or not. I guess it would be, we'll start with 200 to keep it simple. I think I do have an initial value. Then the transform is here, and the reduce is here. The reduce is going to be standard std_min. Yeah, it's the earliest time, right? Constant A, constant B. And then the transform is going to be constant vector. It's v0 plus v. Is that it? Compiler. Return value, no discover. Okay. Oh, that might matter too. There we go. I think that's it. I think that's it. Yeah, there we go. Not too bad. Next, how are we doing? A few more minutes. This one we gotta subscribe at some point. Chunk array, okay. Array, chunk size, return a chunked array. Chunked array Contains the original elements of the array but consists of subarrays, each of length size. Okay. The length of the last subarray may be less than size. Okay. Without using Lodash as chunk. What's this JavaScript? Oh, okay. All right. Sure. This is pretty straightforward. Could probably use a slice or something. So I don't know. We could use a simple loop and just say, I don't know. Let I equal 0, I plus equals size. I don't know. I guess it's I is less than the right length. And we're going to say let result this something like this. I don't know. I rarely use JavaScript these days, so I don't really know. 0 j is less than length, and oops, and j is less than size. Excuse me. What? Intermediate or intermediary or just chunk? We'll just call it chunk. Chunk. I think I can push in JavaScript. Array of I. Let's do. How about this? Why don't we try this one? Something like this, I think will do the trick. Wrong answer. I gotta see the red. Oh, I got a null. Okay, that one's wrong. Okay. It's not. It's I plus j. It's less than. Yeah, that's my mistake. All right, let's go with that. From India. What's up? Welcome. Howdy. Your time is 4:14. Where are you from? How's it going? Navo Diane Life. Hope your day's going well. Welcome, welcome. I'm from the USA, man. USA. American. American. It's 4:14. Dang, it's late, man. It's late. I have quite a few Indian viewers. Quite a few. Have to remember to stream earlier, I guess. All right, how am I doing on time here? I got a few more minutes. Maybe we'll do like 2 more. I didn't want to do too much today. I've been really tired lately. I need to get some sleep. I also, I've been tired. I need to get some sleep, and I still need to shower before I go to bed. So I already solved this one, but let's see if I can describe a solution. Start at this cell of a rows by columns grid facing east, northwest corners, the first row, column in the grid, southeast corners at the last row column. Northwest corner, first row and column, southeast is last row and column. You'll walk in a clockwise spiral shape to visit every position in this grid. Oh, okay, yeah. Whenever you move outside the grid's boundary, we continue our walk outside the grid, but may return to the grid boundary later. Eventually, we reach all rows times column space of the grid. Return an array of coordinates representing positions of the grid in the order you visit them. This is kind of a fun one. Outside the grid's boundary, continue our walk outside the grid. Wait, but why? Oh, wait. Oh, I see. Okay, got it. So the grid it's not a square. Okay, got it. Oh, that's very interesting. So Yeah, I think the easiest way to do this is um, you would start the first row. So you have a size that you work with, and then you have a direction, right? And so at each step, you're going to change the direction. And then at a certain number of steps, you're also going to change the how far, like the magnitude of how far you're going. So for the first row, for the rows, let's say you have m rows, m by n, right? So m rows. Um, excuse me, the number of rows is m. The Let's say the size of the row, let's call it r, row size, like row size. The first iteration is going to be row size. Then the next iteration is going to be column size minus 1. Then it's going to be row size minus 1. Then it's going to be column size minus 1 again. No, minus 2. Or you could do row size minus 1, column size minus 1, row size minus 1, column size minus 1, and then repeat. And then just decrement the row size and column size for each spiral. There you go. That's probably the easiest way to do it. It's a very straightforward question. Yeah, like I said, I already solved that one, so just give that a quick explanation how I could do it, and then move on. Hi, I'm just starting my DSA. What's up, Arav Jane? Hope your days go well. Welcome, welcome. DSA journey currently at array problems. After how many topics can I start solving problems with LeetCode? What I'd recommend for DSA is to actually, you could start solving LeetCode problems whenever you want. Like, what you probably should do is like find common algorithms that are important, and then basically, I think LeetCode has a thing where you can do like, let me see if I get this open here. Let me show you. I think there's a way to do this on LeetCode. I haven't done it, but if you click like greedy algorithms, um, you just click practice, and so you try to find like algorithms, like say let's say you just learned like topological sort, so you go and learn the algorithm, and then you just click this, and then just go do all the top. You really only need to do like 5 questions, quite frankly, but you could do all of them. I mean, there's only 40. It's not that hard. Um, some of the really hard questions though are a little tough. Like some of the really hard ones are kind of like in their own category, and it's probably not a good idea to do what I just described. Um, but yeah, like dynamic programming questions, for example, like these are so varied that like there's no real point in like clicking on this and trying to solve them in this way. Like what you ought to do is um, you basically want to like recategorize the algorithms based off of like the important algorithms required to solve those questions, or reorganize the questions with respect to those algorithms. So that would be the way to do it. That's what I'd recommend. Find the common elements between 2 arrays. Is this JavaScript? No. Okay. Given 2 integer arrays, nums1, nums2, sizes n and m, respectively calculate the following values. So insert 1, the number of indices I, such that nums of I exist in nums2. Number of indices. Okay, so basically these are like the common elements. Um, uh, I mean, the easiest way to do this is one of the easier ways is to take the smaller of the two, and the larger one, no. I think the smaller of the two you sort, and then the larger one, you're going to binary search each of those larger values in the smaller one. Yeah, I think that's the way to do it. But we could just sort one of them and then check the other one. That's probably the simplest way to do this. We're gonna call this v1 and v2. I don't like typing so much, man. V1. We're gonna sort v1. Oh wait, never mind. We're gonna do both of these, don't we? Aren't these always the same? These two? Am I wrong? Oh, they're not always the same. Maybe we'll just sort both of them. Whatever. It's there's some stuff going on here that's a little bit more complex with duplicates and things, but we'll just keep it simple and we'll just run them both ways. It's fine. It's not gonna take that long to think of both. This is not the fastest way to do it, but it's probably not the fastest way, but it's a quick way to program it. So int a1 is gonna be, I hope this works. So for constant x in v1, we're going to say a1 plus equals std lower bound of can I do it this way? Std lower bound of v2 begin, v2 end. Let me v2 end. Actually, I should do this. This is better. V2 begin, V2 end, X. So I'm looking from 1 and 2, and if that's equal to if I dereference this, if it's equal to X, then we found it. I probably shouldn't do it that way. No, not quite. I think it's gonna be a constant. I have to double check that though. If pointer is not equal to 2.end, and now we can dereference. Okay. And you run like the same routine, but on the other side. Just symmetric kind of thing. V2, V1, V1, V1 again, and A2. Swap all the numbers around. Something like this, I think that's the trick. Heart. Hey, what's up, Spooky Styro? Hope your day's going well. Welcome. Hello. Howdy. There we go. That looks pretty good. Yeah, like the really hard questions. I think there's this question is the MCM dynamic programming. Burst limits. Like, let me give you an example of the balance, burst balance. Give you an example of a dynamic programming question that's yeah, this one. Is this related to matrix multiplication? Is it matrix multiplication? I forgot now what it's called. Yeah, MCM. That's what it was. Matrix chain multiplication. So, if you do, yeah, if I understand correctly, is not known to be a faster solution. MCM, it's so likely than interval MCM or interval dynamic programming solution is probably optimal. At least finding a better solution requires research level, research grade effort. Is that fair? Yeah. So this is like this would just be possibly just thrown into the dynamic programming section, but like this is obviously, yeah, that's fair. Okay. But this is obviously like quite a bit more complex than just dynamic programming. Did I submit this? Yeah, I did. Okay. There you go. So this is a reasonable solution. May or may not be the best solution to the like the sorting approach, the sorted and search kind of deal. But it's pretty quick to code. It's pretty quick to program. So yeah. Okay. That's gonna be it for this question. Yeah, like I said, you could probably think of better. Oops. Probably think of better approaches to this. Uh oh. Uh oh. Are we still live? I think we're still live. Let me just check and see. Something bad happened here. Hold on. Goes. Is it working? Hello. Hello. Are we still live? Yeah, I think we're still live. Still live. That's good. Sorry about that. So yeah, it's a pretty straightforward solution. And I think could read this question, I guess. I should get going here. It's gonna be hard for me to read this and not solve it though. I like the LeetCode easies, man. They're quick. All right. M by n difference matrix diff is created with the following procedure. The number of ones in the ith row be ones of row sub I. The number of ones in the jth column be ones column sub j. The number of zeros in the ith row be zeros of row sub I. The number of zeros in the jth column be zeros of column sub j. Diff of ij is the ones in the row of I plus the ones in the column of j minus zeros of row of I minus zeros of column j. Return the difference matrix diff. Oh boy. Oh, that's an interesting one, huh? I mean, sure, I guess you could just, I guess the grid just has ones and zeros. Yeah, I mean, that's fine. So it's going to be an interesting one. I think I can do it this way. So we'll do std vector int, we'll do row ones, row zeros, row ones, row zeros, and then column ones, column zeros. Yeah, I guess we do it like this. And it's m by n, right? So constant m, grid that size. I think it's usually these are non-empty grids, so this works fine. So the rows, columns, we're gonna start with 0 on each. And we're gonna go to so const auto for the row ones. The row ones do for each row. Int r is 0, r is less than m, r. I'm gonna say row ones of r is gonna be the just accumulate of say const auto. This row is grid r dot in dot end 0. So that's an easier one. But the zeros are more like the following. The transform, I think. Turn not constant will be. I think it's going to be not B. I think that works. I could be wrong about that. And then for the columns, a little more complex. What we're going to do, const auto column sum. I guess I'm going to try something kind of fancy here. Const auto, like a lambda or func. I'm going to use a default function too. It's just the identity function. I don't know if this works. I'm going to try it. That's the first time doing this, by the way. I have not tried this before. It's a bit unusual. And we're going to say the column sum is going to be a certain column. Grid. And we have this function. And we're going to say for let's c equals 0, c is less than, let me say m or n, number of columns. This actually should be m. I think, yeah, m. Increment c. So this actually, it's going to be row, but it's going to be result. I'm going to just use int for this result. 0. Return result. I'm going to say result plus equals grid. I'm going to func of grid. And the column is going to change, the row is going to change, but the column is not. Okay, something like this. Column sum. Let's try that. Now we can compute the column sums this way. This might be a lot of extra code or something that's kind of not too complex. I don't know. I don't know. Over each column, and say, I'm not going to have this anymore. I'm going to say column ones, C, column zeros, C, and it's going to be some. And so row begin, row end. Oh, I guess we're not going to have an init value. It's just going to be C, I think. Yeah. And now this is going to be, have the lambda expression. Okay. Now, we can write into the grid. Ints are 0, is less than m, plus r, 0, is less than n, plus this c, grid of rc is equal to, what do we say it was? It was row ones plus column ones minus row zeros, column zeros. That would be, I have to double check what it was, but and this is just me for each row. Something like this. Let's give it a shot. Compiler, of course. Yeah, the zeros we subtract and the ones we had. Okay. Okay. Oops. Where is it? Std accumulate constable. Oh, okay. 2 arguments are provided. Okay. All right. I think I did this wrong. Could do it like this. I think I'm supposed to do constant x or accumulate b, and that's going to be like just. I'm going to use a static cast to make it simple. Yeah, I can try that. I'm not sure if this will work. This one, it might not. What's up, and above? How you doing? Welcome, welcome. All right, did I get another issue here? I might have. I might have. Oh, what did I do? I hit, maybe I didn't hit the button. No, no, no. I did get another row zeros. What did I just fix that? What's going on? Oh, wait. Oops. Oh, whoops. That was the wrong one. Why did I just copy paste this and forget to I did and what did I do? What did I do? I don't know. I think okay, that's a little confusing. Whoops. Mistakes are made. Um, the pitfalls of copy pasting code. I think that's what I did wrong. No matching function. Candidate template ignored. Couldn't infer template argument function. Oh, bummer. Yeah, I was gonna say this is my first time using trying to incorporate a lambda expression inside as an argument in another lambda expression. That's also like basically templated, so it's like a default lambda expression. Yeah, trying to use a default lambda expression within inside of another lambda expression. Yeah, I don't know. I don't know about that one. I could just make this. I could just do this. It doesn't need to be. Doesn't need to be so complex. Yeah. By the way, this may not be correct as well, even though it's. I'm not sure if this will still compile anyway. Okay, it compiles and runs, but is wrong. Okay. Interesting. Well, so these should be probably ints. Static assert. Not static assert, what's that cast? Same thing. There's some confusion on my end as far as like what happens with these different things. Like what happens with the compiler if I did try to make like a default lambda expression there, and then like also what happens with like the type the primitive type like I think they get upgraded. I forget what it's called exactly, but they get like modified to different integer widths. Which I think Boolean is actually a character integer width anyway, so I don't necessarily know if it matters that much. But this is a bit odd. So this is wrong. This one's right though, somehow. Excuse me. So I did something wrong. So the first row should have 2 1s, and we subtract the 0, which gives me 1 for the row tally. Actually, I should have I could have done it that way too. Just take the difference between the 1s and 0s, and I should have done that. That's better. Actually, that's way better than having column 1s and column 0s. That's actually a lot better. I did this wrong. I did this wrong. Are you ready? Better way to do this. Much better. Okay, we're gonna say row diff. That's better. Forget row zeros. We're gonna do row diff. And we're gonna say const int x, say return x minus 1. So we're gonna do x is greater than 0. We're gonna return x, otherwise negative 1, basically. Or really just 1. Doesn't really matter. Either one. Yeah, there you go. That's the row diff. Okay, that's better. What you really want is the row diff. And then in that case, I can do row diff plus column diff. And then I don't need this complex like column sum because I'm only calling it once now here. So I could just copy paste it right in there. This is taking me a lot longer than it should, I think, by the way. The row diff. This also shouldn't be the number of rows, it should be the number of columns. The size of the row is n. That was a mistake on my part too. Yeah, it swaps. So the number probably better is to do column size and row size. It doesn't really matter. I guess now that I've vocalized it, should be. I tend to forget that mixed up and get that confused. But yeah, the number of rows is the same as the column size, and the number of columns is the same as the row size. So m is actually the column size, and n is the row size, which is a mistake there. That might have also been why I was getting the error before. So now we're going to say column diff. Whoops. What did I do? Oh, let me do that. I meant to copy paste this. Cut this. There we go. So there, that's a lot simpler. Instead of function, we're just gonna put this here. Row, column. I'm gonna do 1 or -1. This is greater than 0. Okay. Yeah, you could do I'm thinking of a function that's not an if statement. If you get if it's 1, you'll still get a 1, but if it's a -1, if it's a 0, you get a -1. I think you do like 2 times x, you do 2 times x minus 1. I think that works. It's better than if statement. Yeah, that's better. All right. Something like this is a little bit better. Let me see how this goes. Let's chat to it. What's up, chat? Compilers. Okay. Jeez, man. Compiler's not happy with me today. Compiler's not having it. It's like, what are you doing? What are you trying to do over here? Hmm. I did this wrong. I feel like I did this wrong. Row diff. Yeah, this is confusing. Row diff for a given row, column diff for a given column. So actually I did have that right the first time. Okay. All right. Going quick here. Okay. So what's the compilation error? Oh, there's yeah. I remember now. Gotta have an it's a two arguments accumulation. That also might be why this is wrong. Hmm. So many slight mistakes here. Okay. There we go. All right. Gosh. uh, How's that for a last question to end on? That was a little goofy. It's pretty fast. It's okay. Oh my gosh, man. I don't know, man. I have no excuse. I have no excuse. I just. All right. Sometimes I struggle, you know? That one took a while. That took a good like 10, 20 minutes. It took a while. There may be a faster solution to that, by the way, than that. But this is okay, I guess. Um, yeah, it's pretty, yeah, I could have done that a lot better. Like if I had, I guess, thought that through a little bit more initially, I could have written it better and would have been a lot faster. Also, I tend to forget the accumulate function has two arguments as inputs. I think I've been using the accumulate transform reduce quite a bit, so it's transform reduce a little bit different. And then yeah, that's okay. This is okay. Apparently, there's a faster way to do this, which I'm thinking about now. I'm like, what's the fastest way to do this? I'm sure there's an even faster way, but this is reasonable. This is reasonable. I'll tell you what, there's probably a dynamic programming solution to this. Maybe. I don't know. If you take the first row, you calculate the sum, and you calculate each of the columns, you could avoid, you don't need to store as much memory as I've been storing. You could go row by row, just save the columns, go row by row. That's an interesting question. I'm not sure. I'm not sure. The fastest approach is probably just a little more, just like a little more complex, I guess. A little more involved. But this is reasonable. This is reasonable. All right. I think I'm going to end there. Thank you all for watching. It's been, yeah, I was going to end a little while ago, but that was an interesting question. Um, have a good rest of your day. Thank you for watching. If you like the stream, don't forget to subscribe and give it a like. And yeah, I'll be streaming more in the future, I anticipate. I think so. Although we'll see. We'll see how it goes. Let me not make too many promises. But yeah, the plan is probably to try to solve um all the LeetCode problems. And somewhere in between, I think I might look to do like mentoring, tutoring, coaching, that kind of thing. Because I'm not bad at LeetCode. I'm okay. I would say I'm okay. And then I worked as a software developer for a while in a corporate environment. Worked on algorithmic trading systems. I did client services, sort of. Technically, my role wasn't exactly. It was client facing, but it wasn't exactly client service. A little more complex, but um, it was a good job. And yeah, if folks are interested in that sort of thing, I'll probably get that going too in the future. Um, but yeah, thank you all for watching, and you guys have a good rest of your day, rest of your night. I think some of you folks are up really late, so I appreciate that. But yeah.